Okay, this is a quick video on these two symbols, R2 and R3. So we'll introduce it with this idea of this. And basically this is just when you want to, what they call it like multiplication of two sets. So the cross product or the Cartesian cross product means when it's sort of an operation between two sets. So suppose we have these two sets here, A and B, and we can basically what we're going to do is we're going to combine them by taking one from the first set, one element from the first set, and one element from the second set, and forming an ordered pair, what we call an ordered pair. So that means something like, so we're going to take 1 and u, so we get 1 comma u, we're going to form 1 comma u. Then we're going to take 1 and v, we're going to get 1 comma, we're going to form 1 comma v. Then we're going to take 2 and u and form 2 comma u. Then we're going to take 2 and v and form 2 comma v. And then we're just going to continue until we exhaust all the possibilities. So we have 1u, 1v, 2u, 2v, 3u, 3v. So we just exhaust all those possibilities as an element from here and an element from here, and we form these ordered pairs. And then we just call that a set. We call it a set. And then we give it a name, and that's called the cross product of A and B. And that's written like this. That's written like this. So A cross B is this stuff here. So it's just a set of ordered pairs where you draw the first element of each ordered pair from the first set and the second element of each ordered pair from the second set. And so that's called A cross B. So what does it have to do with this? Well, we all know what we mean by the real numbers, and usually denote that with an R. So we mean going, this all the numbers on this line, all the real numbers. So that can be 1.2 or 1.8 or the number pi and the square root of 2, all of the numbers, those are called the real numbers. But we can think of this as a set also. It's a set of numbers. So if this is a set, R is the set of all real numbers. So we could think of R cross R, because that's the same idea as here. We have a set cross another set. They happen to be the same set, but still it's a set cross another set. So we could imagine all of the different ordered pairs that we would get. Of course, there's going to be an infinite number, but we'd have many ordered pairs. We'd form ordered pairs, and we'd say, okay, the first element is some element from R, and so we could have 2, and some other element from R, maybe we could have 6.3, and that would be one element in the R cross R. And of course there's going to be an infinite number, so we're not going to write them all out. But we could imagine all of the different such ordered pairs. So we'd have a huge number of them. And another notation for this is this, R2, R squared, or R2. So that's what R2 means. It just means R cross R. So it means this huge set of ordered pairs. Now, of course, with each ordered pair, we can draw the Cartesian plane, or the xy plane. We could have the xy plane, and each of all the elements in here are ordered pairs, so we can think of them as points in the xy plane. And of course we're going to get every possible point in the xy plane when we do this. So we can just say this is equivalent to the xy plane. For every point in here, there's an element in here, and for every element in here, there's a point in here. So they're equivalent. So we can think of R2, which is the cross product, Cartesian cross product of R with itself, as the xy plane. And then we can also take the cross product of 3 sets. So you could do A cross B cross C, and that's going to give you ordered triples. So you'd have like, here we have 1, comma, v, comma, and suppose we had some other set c, and that was equal to something else like t and s. Then we could do like 1, comma, v, comma, s, for example. So we're going to get ordered triples here. And so we'd have a set of, if we did A cross B cross C, it would be a set of ordered triples. And also we could do R cross R cross R, and that would give us, like 2, comma, 6.3, comma, 8 or something. And that we could think of as points in the, whoops, that should be a straight line, points in the, in R3. So R3 we can think of as R cross R cross R, and R2 we can think of as R cross R. So R2 is the set of ordered pairs x1, x2, where x1 and x2 are both in R, and R3 is the set of ordered pairs where x1, x2, x3, where each of those comes from R. And then we could also talk about R4. Now, if we do R4, we're not going to have, we can't draw it like we can draw this one, and we can draw R2, but we can still talk about R4, and that's going to be ordered, like there are going to be 4 elements in here. Or we could talk about R5, that would be 5 entries in here. Or R6, there would be 6 entries in here. Or generally speaking, Rn, where we would have n entries in here. So that's what we mean by R2, R3, R4, and so on.